Hi. Yeah, GPOs from source, or Mark suggested me this morning some other titles. GPO as code, GPO ops. Who am I? Kees van Vloten. I've been working as a freelancer since 2011. Been using Samba in infrastructure thingies for a long time, and started with Samba-ID around 2020, and I built integrations on top of that. But yeah, the core part is AD, and some important component of AD are the GPOs. Anyway, some thing about history. Where are we today with GPOs? Why do I really want this from source thingy? A GPO is comprised of different components. What are they, and the achievements of this project? So my journey basically through the world of GPOs. It started really early. Even Windows 90 something had already some kind of way to provide centralized policies through the net logon share, and then the current implementations, they started with Windows 2000 when AD came along. Stuff moved to the sysvol share, formats changed over time, components were added, and yeah, client-side extensions will go over that. So it's basically, David said it in the last presentation, it's a mess. So we have multiple file formats, we have stuff that is stored in LDAP records. We have permissions that are pretty important on LDAP and on files, and nothing of that is really well documented. There are fragmented online sources. Then there's David Mulder with his book about the Linux GPOs. But yeah, I looked more onto the Windows side, although it is working generically. So there was quite a bit of going through it, and you call it reverse engineering probably. So why do I want GPOs from source? I want to have a backup. I want to be able to revert to a previous version. And this requires them to be stored in text format. If you want to put them in Git, binary objects are no good. I want to be able to use them in different domains and to identify them by name. UUIDs are not for humans. And when you have them as source, you might as well use that source as the documentation. And the other side of the documentation is that this whole journey I went through gave me some documentation about how the whole GPO thingy works on Windows AD, or in this case, Samba-ID. So what kind of components do we have? We have the file system that lives on sysvol. It contains directories. It contains ini or INF files, which is basically kind of the same thing, different extension. It contains XML files. It contains registry poll files. Then we have LDAP, which for GPOs has 3 records, the top level, the user, and the machine. And if you want to have WMI filtering, you need another record. And there's the permissions, which comprise of permissions on the file system, permissions in LDAP, and a link of the GPO to an LDAP object. So the file system bit. It lives on sysvol, which should be replicated around all domain controllers, and Windows just connects to one of them. You never know which one. It lives in the directory policies under a directory with the UUID as a name. Not very handy if you as a human go through this directory tree. And then you have two subdirectories for a machine and the user bit of the GPO, where the machine bit is always applied to the client machine. The user bit is then applied to the user that logs in on that machine. It has a GPT-ini, which contains some settings, but not all. Some settings are elsewhere. And before we continue, let me start generating some GPOs on this screen. Okay, because it takes a while. The current implementation uses Ansible, and that's not very fast. All right. So, ini files. They are the oldest incarnation of GPOs on sysvol, and they use the DOS formatting with CRLF line endings, and they use Windows UTF-16. So would you want to create them from Linux, you have to do some extra work to make them work on the Windows side. They look like the example over there. If it's an INI or an INF file, so you have this mandatory content that you have to get from somewhere. The easiest way to get it is to go into GPMC, click it together, and then look at the output on the sysvol share, and save that. Convert it back to Linux, and then save it in your Git. Most of these have mandatory directories, and they can be empty. So you see a directory listing below there, where you have, for example, scripts startup and shutdown, and these directories, they are not used at all, but they must exist, otherwise your policy doesn't get applied. Windows will create them for you if you do this from GPMC. And by the way, the last point, or the last two basically, GPMC has a hard-coded UI for these older GPOs. And it uses client-side extensions. That's a list of UUIDs that you have to add in LDAP. And they have to match exactly this policy, but then in UUID form. Otherwise, it doesn't get applied on the Windows machine. So Windows uses it to select some DLL that applies these settings on the machine. Then we have the XML variation of GPOs. And of course, they don't use the same file format. For some reason, this probably happened a bit later in time, and they thought, well, it's XML, and now you can use Linux file format with line feeds only and UTF-8. It's a bit simpler if you want to generate them from the Linux side. But yeah, it's different than the previous format. And there's an example here, and I marked it yellow. You have to add the change date, and it has to change with every change in your file, or in your GPO. With the other ones, the file can stay constant even when you change stuff. If you want to change some LDAP flags or whatever, well, here you have to update the date as well inside the file, and it needs directories, and it needs client-side extensions, and it still has a hard-coded UI in GPMC. So then we have the most recent incarnation of this whole thing, which has now binary files. They are registry files, and they have a simplified directory structure, because the file is always called registry pol, and it can just exist on the user side or on the machine side. They have a standardized client-side extension, and this is what the client-side extension looks like. It's always the same. And they have a flexible UI, so it's easier to create new ones. You need to make an ADMX file and an ADML file, and you put them on the sysful under policies, policy definitions. And the ADML file is for the language. So that's the language that will be used on the ADML, what is it? GPMC side to show the text on your screen. If the ADMX file does not exist, the policy does not get applied. So what can we do on the Samba side with these binary things? A year or two ago, I asked David about this, and he said, well, we can implement something. So we came up with the idea to create a JSON file with all the settings, and you can then just say GPO load, the identifier of your GPO, and then you specify the file, and it will just put this content in that file, or in that UUID GPO. So the content of the file goes into the UUID GPO. Pretty simple. But how do you know what kind of registry settings you have for this GPO? Well, GPMC, you click it together, it generates a GPO for you, and then you run samba-tool GPO show with the UUID, and it will show you the whole JSON file. So it's an easy way to get the JSON file on your screen, and then you have it as a source, and you can put it where you want. Okay, finally, we on the file system side, we have the GPT-ini. Which came with the first incarnation, so it is UTF-16 and CRLF line endings. It doesn't contain very much, but it contains the display name. So under that name, you'll see it in GPMC. And it contains a version number, which is a 32-bit number. And it's split into two 16-bit numbers, which have the version for the machine policy, and the other 16 bits have the version for the user policy. Now, I don't really know why you want to have different versions for both, but if you edit it through GPMC, it will individually change those numbers. So if you look at the number above there in the example, that is version 5 for the machine and version 3 for the user. The easier way, if you do this with generation code, is to increase both numbers always. Yeah, there are Samba tools that can output this, like GPO show with the UUID, or if you want to get that for all GPOs, then you can do list all. So, then the LDAP side of things. There are 3 records generated. Basically, 2 of them are usually empty. The machine and the user record. The top level record contains the settings of this GPO. And if you want to use WMI filtering with your GPO, you need a separate LDAP record for the WMI stuff. So what does an LDAP record then look like? Well, as I said, the only thing that is interesting is the top level record. And, I marked the interesting attributes with yellow. So flags determine it's a number 0 to 3, and it determines whether it's enabled or disabled. And you can also enable user only or machine only. Then we have the client-side extensions for user and for machine. We have the same version number as in GPT-ini, so it must match. And if you have a WMI filter, you have a reference to the UUID of the WMI filter. There are some Samba tools that you can use to show this. Flags, for example, they are shown with GPO show. And the whole record you can do with the LDAP search thingy with the DN. And then the DN is the UUID with the place where they are held, so policies, system, and then your domain. Would you have a WMI filter, then you need this additional record. So I created a WMI filter to apply this policy to Windows 10. It just needs these two yellow fields, the name and the WMI code to do it, which is interesting. Windows 10 is called 10.0.1 and then something. Windows 11 is called 2 and then a % sign. So it's not 11, so it's 10.0.2. Permissions. So we have different permissions. First of all, we link the GPO object to an LDAP container, which is then the root of the place where it gets applied. I usually tend to link it to the root of the domain and then filter by group. So this is not, the link is not the most interesting thing in that respect. Permissions are more interesting because they have to match between the file system and LDAP, whereas LDAP contains a bit more because it contains the security filter groups as well. So if we look at delegation, then that determines who can basically see the policy and or edit it. Being able to read it is important, but it's usually set to authenticated users. So everybody basically who is authenticated can read this policy. If you can't read it, it doesn't get applied for you. Then we have the security filter. It's in the middle here. And sorry, yeah, I'm from the Netherlands, so I use a Dutch version of Windows. So you have the link, the security filter, and WMI, and that determines the scope. WMI, I don't know, it's probably not used that often. The link is usually set to the root object. So the security filter is the interesting bit. It's an AD group, and if you're a member from this AD group, member of this AD group, then the policy gets applied to you. So how do we do this on the file system? The easiest way is to apply it at the level of the top level, the UUID directory. First I tried to use POSIX ACLs with setvacal, but it's impossible to set that exactly as Windows likes it. POSIX ACLs are limited somewhat. So that doesn't work. And of course, it must be equal on every domain controller, because you never know from which one the policy gets fetched. In order to get that, if you use set fecal, it will update the ACLs. So you must ensure that your application also replicates ACLs. If you use the other methods below here, samba-cackles, and then do it over SMB, that's more accurate. That actually works pretty well. But it will also set X-atters. So your application must be able to replicate X-atters as well. And most applications don't trigger on changes on equals or X-atter only. So in order to trigger your application, you have to do a touch or something of your file, and then it will replicate. And on the file share implementation of AD, there are some limitations. It's not exactly the same as the file sharing of the file server. To get the ACLs, the Windows ACLs exactly right, in some occasions you have to do an anti-ACL sysful reset. So that will fix the ACLs on the server side. Now what do you have to set? That's this big list here below. And you can see near the bottom there's a for loop to set the filter groups in it. So with this you can programmatically generate these ACLs and get it right. Then we have the other half of it, which is the LDAP half, and it must match. So with LDAP we have 3 records, and also here you can just set it at the top level record. But unfortunately LDAP doesn't have that nice format that we can use as an SMB, so we have to use the SDDL format, which is kind of obscure. You can read it with samba-tools, ds-acl get. Setting it with that tool is a bit harder, doesn't work properly. But you can replace it with LDB modify. And as in the SDDL format, you need to resolve the group to an SID. So, and then looks like something like this. You can find the UUIDs on the bottom, and you can resolve them to names. And there are tools to interpret this whole big mess. But also this can be generated by code. So then, we can write some pseudocode. So we can create the WMI filter with LDB modify. There's the Samba-tool to create an empty structure of a GPO, so GPO create. The only thing is that you can tell it to do the LDAP stuff on your local controller. You can't tell it where it will do the SMB stuff. So it will land on any controller, and before you see the files you have to wait, or what I lately do is I just put them there on my local controller, and then I trigger a replication, and it overrides the remotely generated stuff. So that's the second step. So we set the ACLs correctly. Then we create extra directories, but we do it with SMB client. The only thing is, if I do SMB client myself, I can say that I use this DC host, and it will land here and not just anywhere. In INI files, So you first convert them from Linux to DOS, and then you can upload them XML files. You don't need to convert them, but you need to put the date in it. Registry pool files, you can load them from the JSON file, and then you have to do some LDAP update to get the client-side extensions, the flags, and the WMI filter. Of course, we need to set the permissions on LDAP, and then we increase the version number in GPT-INI and in the LDAP record. And finally, we link it somewhere. So, with this, we can't move everything to source. We can create a specification file that combines the security filter groups with GPOs. We can create templates for the files. And if we insert variables and we use Jinja, for example, then we can make them domain independent. And with the if we implement the pseudocode on the previous slide, we have the whole thing to generate this, and that you can store that all in Git. Now, let's have a look at what that actually looks like. I think here, yeah. So I have this really small screen, which is indeed too small. So what I did here is I made a JSON file with the specification. So we have the WMI filters separately because they need to be created before you can create the GPOs, because otherwise you can't reference to them. And then the group policies itself. So what are the security groups? And then the INI files that we use. So it refers to files here on the left side. Do we need to create directories? In this case, we don't, or at least here in the example, I didn't add that. I did add the reference to the WMI filter and to some extension. So this one has more client-side extensions. It has some variables. So in this case, I want to set up a service. Let's have a look at the service. This is a Jinja template, so it will loop over the variables that we give it. This section will be looped. Oh, and then, of course, we need that special variable change date to insert it every time that this file changes. We then move back. We have the third incarnation, which is the registry pool file, and it needs some JSON spec. And this is what comes out of GPMC and then Samba GPO show. Yeah, give me, where's the other one? Oh, did I miss it? Services, I think I missed it. Okay, it's too bad. Don't have that here. The INI file is something I can show. And I started doing this implementation to get the whole stuff together. It still needs testing and so on. So when it's ready, I'll put that on GitHub. In the meantime, on this screen, oh look, that's always what you have with demonstrations. But maybe we can check whether Windows gave me at least one of the policies. Okay, and then refresh this whole thingy. None of them. It's too bad. It failed at the first one, I think. So there were, I created three policies that had the name demo in it here. But yeah, it looks like they haven't been created. So that's not something that we can see now. And I guess I know why, because I used some capitals in it. Probably it doesn't like the capitals, because I tested this earlier without the capitals, and I thought capitals is handy because it's easy to recognize on the screen. Bad idea. So yeah, that's basically, oh yeah, I can't switch back with when the virtual machine is active. That's basically it. Questions? Okay, if no questions, then thank you very much.